Hey, good morning, Imran. How are you?
Yes, I'm good. How are you?
Feeling a little bit better than last week. I've actually conducted the I've caught there's a flu apparently that's going around. So I've
Mhm.
I've caught the flu and it's just been horrible. I never felt this sick in my life. It is just a very bad flu, man. Um, I'm recovered now, but there's just still the cough and like still a bit of a sinus still stuck in my chest, but hopefully next week everything will be all right. But at least can focus and teach at least a little bit with coughing. But at least I can teach. That's a good thing.
Right. My
Yeah.
my mother was sick, so I traveled back home.
Oh, did you?
Yeah.
Oh, are you still back home or are you came back?
No, I'm still back home.
Oh, you're still back home. Okay. Hmm. No worries, man. I hope everything back home is where is for you.
Pakistan.
Oh, Pakistan. Okay. Which part of Pakistan, man, you're from?
Lahore. It's near Lahore, Gujranwala.
Oh, okay. That's the northern. Is it the northern northern part of Pakistan?
And it's close to northern. Yeah.
Close northern. Okay. Yeah, I know a couple of my friends. They're from. Um, I can't even think of the name, man. I'm still getting that. The fogginess from the flu. The flu gives you fogginess in the brain fogs. Uh, it's a nice place, man. Is it Karachi?
Uh,
Karachi,
Karachi is near the ocean, like a coastal area,
coast area, right?
and
Hmm.
yeah, the mountain area is like past the Islamabad towards the north, and that's
Right.
where the K2 and Naga Parbat and all other mountains
Yeah.
are.
Right. Yeah.
So it seems like no one is here today.
Yeah, I think everybody's hasn't woken up, but we'll still conduct our class and we'll put the recording in. That way, today is going to be another concept. It's going to be IP addressing. So we're going to talk about IP addressing, IPv4 and IPv6. A bit about IPv6. IPv4 we're going to touch base on, and then I'm just going to do a lot of examples on IPv4 and how does subnetting work in there.
Okay.
Okay. Sorry, and I might put myself on mute just so I can cough and then come back. Okay, so just don't mind me. It's just
No worries.
yeah, a bit on. I'll just quickly unmute I'll put my mic away if I have to cough a lot. But I have a cup of water here, so I might mm, just to keep the throat, moistened up. Okay, so today we're gonna go back and forth between two different instruments. One is gonna be my slides, and two is gonna be I have a Microsoft whiteboard here, so I can draw and show you guys um, examples. Second, okay, yeah, very good. And these slides are not very friendly, but they get the job done. Just so we can talk about it, it's going to be very good concept. Concept that everybody needs to understand for CCNA, especially subnetting. It's a very good concept that you need to understand for you to do work with the routers and those type of things. Okay, so let's get started. And if you have any questions, feel free to ask me when you just unmute yourself and ask me. Okay, no problem at all. Okay, so binaries, they work in a way, of zeros and ones, and it's literally how a signal is traveled through a wire. Zero means it's off, one means on. I'm sure most of you guys if you guys have an IT background, there have been a course on binary conversion. How does it work? It's basically turns on and off. That's all it is. Okay, and that's how it's traveled. And the on and off will equal a certain degree of value. Okay, your computer reads zeros and ones. That's all it reads. The other things happens in application layer. or other places, but your computer's basic language is 0 and 1s. Okay, that's how it starts off as. When you're counting binaries, it works in zeros and ones. There's only two different digits you can only have. It's either 0 or 1. Okay, and we always count it with a 2 and a 1 column. And if it's a 0 and a 0, the sum is equal to 0. If it's 0 and 1, then it equals 1. If it's in the 2 column, there's a 1, and on the 1 there's 0, it equals 2. It's because the 2 is lit up. And if it's in 2 and 1 is 1, 1, it equals 3. Okay. And this is a basic binary math. It might not make too much sense, but this is how it reads from your very, very basic level. Okay. And as long as you just memorize this concept, you can turn any numbers into binaries. Like, to be honest, in your CCNA exams, you don't need to memorize this. Where you might have, what you will have to memorize, I'll tell you in the next coming up slides. There is another column for you to convert IPv4 addresses, binary conversion, the subnetting. You might have to do binary, and that's the thing you have to memorize. And remember, IPv4 address is a 32-bit address. Give me 1 second. Oh, somebody's asking for the class link. Okay, so usually in IPv4 address, we call it octets. So there's 4 different dots. Okay, perfect. So Manjit's here. Manjit, we just got started right now, so no problem at all. Okay, so
Okay, thank you.
no problem. So what I'm going to do is I'm going to go back to my whiteboard here, and I'm going to just refresh this over here, and I'm going to share my Microsoft whiteboard. Okay. So how IP address works is this. We call it octets. Okay, so remember when we saw IP address last week, we saw it as 192. There's a dot over here, 168.0.1, right? These are just dots, okay? So this is actually what we call as octets, OCTETs, okay? So these are what we call octet. This is what separates each of those IP address bits, okay? Each one of these bits, each one of these sections holds a value of 8 bits, okay? So this holds, so if I was just do this, let's say if we do this, right? It holds 8, 8, 8, 8, okay? So that would be what? 32 bits in total, right? 32 bits in total, okay? The IP address's value, 32 bits. This is what we call a 32-bit system for IPv4. IPv6 works in a different bit sections, which I'll explain to you guys later, but let's start with the IPv4 first, okay? So now, let's say if it works in a 8-bit, right? Each octet itself is split into 8 different bits. How it works is when you want to do this is, let me just move this here. How we would calculate this is, let's say we have this, right? So let's say if I was going to draw the sections here, so this is a different section over here, okay? There's a dot over here. This, right? So this is how you'd see this as in IP address ranges, right? So in here you have 8-bit, 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 right? So what we consider from a binary conversion standpoint is, let's say we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's 8 stands per these sections. Okay, there's eight sections here, 8 bits per section, and each one of these bits will be starting from 1, 2, 4, and this is doubles, right? 8, 16, 32, 64, 128. Okay, because we're counting with the thing, right? So this how it would be. Okay, just move this up here. Okay, this is for one of the octet itself. Okay, so let's say if we want to count the bits, right? If we put in 0, 0, 0, 0, 0, 0, 0 here, which would equal 0 bits, right? And let's say if we do the same thing here, right? If we do here 1 and then 1, 0, 0, 0, 0, 0, what would this equal, guys? If you add these up, so the 128 plus 64, what would that equal? That'll be 192, right? Because 128 plus 64. So if you just open up a calculator, 128 plus 64 would equal 192, right? So this value would be 192. Okay. And same thing happens the other way, right? If we add in the plus the 32, so if it's 111 here, you'll just keep on 0, 0, 0, 0, which would equal plus another 32, which will equal 224, right? And if we do the same thing, if we go on like this, same thing like this, which I'll just show you here in the slides. As we add on those binary bits, it'll equal 182. Okay, that's each one of those octets will have 8 bits, right? 8 bits, these are the value. Okay, this is how you would convert them. And it literally it literally will go on like this. Okay, and these are the values, and you see the ones added, the values are added to 1. Sorry. So when the when it's everything is 1, it'll become 255. Okay, which is the last usable bit on the network itself, which we'll consider as broadcast. Okay, and I'll explain what broadcast does and why it's important. And this is what makes the need for us to split the network. Okay, the broadcast IP address itself, 255. Anything that ends with 255 on the network portion, on the host portion, will be considered as a broadcast itself. Okay, and this is how you do your calculations for IP address. So let's say if we want to do if we want to do a calculation based out of if we want to do a calculation that's based out of 192.168 .0.1, right? How that would look is, let me go back to here. So basically, let me just go back here. So if we were to do 128, 64, 32, 16, 8, 4, 2, 1, right? This is a value. So if for each one of these octets, if we want to get the value for as if our IP address is 192.168.0.1, which means the first one has to be 1, 1, 0, 0, 0, 0, 0, 0, right? This would equal 192, right? Now, if we want to have 168, what we need to do is we need to have, so let's say 120, 168 minus 128, 32. Okay, so we would have to have one here, and one here. And these would all be zeros. This would be 168, right? And then we want to have 0 means 0, 0, 0, 0, 0, 0, 0, 0 here. And then if we want to have 1 at the end, this would be 0, 1. So this would equal 192. This will equal 168. This would equal 0. This would equal 1. Oh, sorry, you guys can't see that here. Does that make sense, guys?
Yes.
Yeah, it's a
Yes.
yes. It's just a binary calculation. Once you guys understand this, even in the exams, it's quickly, as long as you can write this table down, and if they're asking you to calculate the net from this binary to IP address, it's very easy once you start writing this table down very quickly on a piece of paper, or if they have, I know if you're doing proctored exam, they might have a little note sheet you can open up. Just write down 128, 64, 32, 16, 8, 4, 2, 1, right? As long as you memorize this number, and then you just write these down, you can easily calculate your IP address. Okay, it's just a fundamental understanding. And for IPv4, IPv6, sorry, it's slightly different. Um, IPv6 might look like it's very complicated, but I'll show you another way how you can do that too. It's not too bad. It's not too bad. But in the exams, uh, they don't ask too much about IPv6. They do ask about IPv6, but it's not as in depth as IPv4. Okay, they wouldn't ask you very in depth on it. Okay. And this is a very basic concept of IP, binary to IP conversion, or IP to binary conversion. This is a table you'll use. It is a 32-bit system broken up into octets. Each octet is 8-bit value, okay? And how we get 8-bit is the same thing here, right? So this is considered as 1, 2, 3, 4, 5, 6, 7, 8, okay? This is the 8-bit, okay? Each octet itself, okay? And let's say if we are getting a subnet mask is calculated the same way, okay? If we want 255.255.255.0, which is, all of these would be considered as 1, except for the last one to be 0, right? Which will just be 0, okay? And just so to make it easy for you guys, just if you guys want to just write this table down for you guys, so you guys understand that this is what the table will look like, and this will give you a value of each one of those when it's turned off. Everything is turned off. What is the value that it'll equal to? Just so you guys remember, it's a very simple table. I'm sure you can create this by yourself or get it off of Google as well. This one I just created in Sheets, okay, just for the class purposes. And these are the value that you can have. um, there's a rule called continuous bit left to right. They no longer use this predominantly in networking anymore. It states that all all same numbers should be clumped up in the first, right? So if it's like, if you have if you want to create a value, this used to be like this. It's to make it more it's to make it more efficient. It's for efficiency purposes, right? So if you have ones, you don't want to have, 101 0 0 0 like that, okay? Especially the starting octet itself, they would consider it to be, either have 1 1 0 0 0, or it starts off with the same numbers, and then it ends like this. It's a good pattern to follow. These are just for the starting octets itself, the starting. So which means, this the bit value where it starts off at here, right? So you see when it starts off at this section over here, especially for when it starts off like this section over here, they will try to make it so that, it starts off with a even, like, it's a very good start. It's either starts with 0, continues on, and then 1 comes afterwards, or starts off with 1. It's not mix and match, okay? It's not really used anymore. It used to be a very good thing. It's efficiency purposes, okay? A lot of places, older places, still use this right now, but it's not really a strict policy that everybody follows, okay? But when you go into classes and everything, which we'll cover right now, we'll get a bit of more in-depth understanding of it, okay? Any questions so far, guys?
Have any
No.
questions?
Okay, no questions, right? Okay, perfect. Very good. Okay, so I want to talk about the broadcast. So what I remember, I mentioned the last IP address on a network. So how how it works is this: on any calculations, right? We did was 0 to 255, right? So that's the number that we said that's available. You will never be able to use 255. It is considered as a broadcast address. So what is broadcast used for is pretty much any computer on the network itself will need to process this address. Whenever broadcasts tell the device, hey, there's these many computers on the network, ask where are you located. It's basically it's almost like a microphone that's telling everyone, I'm located here, this is where the information is, this person's looking for this information. It's just like a loudspeaker person who's just speaking constantly, right? And the worst thing is, all nodes in your network must listen to it and answer to it. So which means it has to stop the process what it's doing and process broadcast first before it does any other task. And that is the power of a broadcast that it has. Okay? The worst thing is when you have a very big network, and we'll get into what I mean by very big network, and you'll see what I mean by that. It causes your systems to be slower, especially your IPv4 address can have a maximum of 4.29 billion addresses, right? That is the limitation of IPv4 addressing. It's 4.29 billion address, I believe. So it gets very, very, crowded with just broadcast. So with the help of subnetting, we can split them up into smaller networks, so we can make the network much more faster, and also isolate from different sort of security incidents, or for troubleshooting purposes, right? When we have a smaller network, it's easy for us to manage those rather than having a very big network when it's just unnecessary. Okay, usually on any network, anything that ends with the 255 you cannot use. It's considered as a broadcast, and each device must receive and process a broadcast. Works fine on a small network, but causes issue on a large one. Okay, so every broadcast is delivered to every host, every node itself. Each device must stop and process it. More host equal more total CPU usage on all the host device itself. Creates unnecessary workloads across the network. Okay, when there's a larger network, some protocols generates many broadcasts. ARP, DHCP, discovery, and NetBIOS. And when we later go on to these courses, you'll understand what these protocols are used for. When many devices send broadcasts simultaneously, it leads to congestions, packet loss, and latencies, known as broadcast storm. And this is a term that you guys want to memorize. It's called a broadcast storm. It's because in a larger network, it creates there's just too many noises for your computer to process, and because broadcast is a leader, your computer must take the information, process it, and answer back. It has to drop what the task it's doing, right? When it's getting 4.2 billion requests from within a network itself, your computer cannot handle. It will crash, and it's called a broadcast storm itself, okay, on a larger network. And also this can lead to a switch flooding. There's something called switch flooding. Switch forward broadcast out to all ports. Your router does not care about broadcast itself. Your router does not really do broadcast, but your switches does do broadcast, which we'll see in the packet tracer example. What I mean by this is your switches will forward broadcast a request to all the device that's connected to the switch itself. Larger network means more port are being flooded with requests itself. I don't know if you guys remember when we did the simulation for remember we did a simulation for the ping, and we did it in the packet tracer. Sorry, when we did it in the packet tracer, we saw that the packets were getting sent to every single computer. We had 4 computers, I believe, and 4 computers getting the packets continuously. That is a broadcast signal itself. It's pretty much saying that this computer got a request to where are you located. Are you here? Are you here? Are you here? Right? Within the local network itself, this is what it creates. On a smaller network, it's fine, but when you get beyond uncontrollably large network, it does crash computer, and it slows down the network significantly. Okay, and results in slower traffic for all devices, not just one device. All device slows down. Okay. And end device waste resources. So device must inspect every broadcast thing, and that's the thing, right? So when a broadcast sends out where you're located, every device must say, no, I'm not him, I'm not this, I don't know where this is, or request saying that where this device is located, right? Or I'm here. So it wastes resources and cause interruptions for PCs, phones, printers, servers, and your phone line. If it's on a VoIP phone line, it will slow down your VoIP phone line. You might hear latency with your phone lines. Your printers will have packet losses, printer issues. Your servers might have received requests lower. It's all these causes because of broadcast storm or over request of broadcast within a network itself. Okay, and usually there's a cyber secure. Yeah, go ahead.
Yeah, are you sharing the slides by chance or
Oh, let
just
me. Yeah. I was just going to talk about it, but yeah, I can show the slides. It's not a big deal.
okay, thank you.
Yeah, there's nothing like, it's just a very basic slides. But yeah, like it's sorry, I'm still recovering from the flu. I was just telling Imran as well. So yeah, so it it creates a barrier for your networks, and it creates a sort of a, a latency for any of your device inside your network, and it has no way of getting past it. It has to process it, right? and and this is why we split them into a smaller network, manageable network, okay, even within a bigger organization. And ARP traffic growth. So ARP uses broadcast to map IP to MAC. So what I was telling before with this broadcast is, in cybersecurity, there's actually an attack called broadcast overflow. What we can do is we can actually create simulate 10 million or 20 million broadcast requests to pretty much all the devices. It will crash the network itself. So it's called broadcast spoofing or broadcast poisoning, and there's something called ARP poisoning as well. That's part of a cybersecurity, right? But just want to give you guys the idea of broadcast can actually lead to a network crash. It is one of the easiest way to crash a network, okay, on a large scale network or in a small scale network too. Um, ARP, you guys will get more introduction to ARP later on, but ARP uses broadcast to map IP to MAC. So pretty much your broadcast will ask where you're located, where you guys are, what is your MAC address. It gets all the information, collects it, and puts it into a place where it can it puts it into a place where it has a map. It says, okay, this computer, this IP address maps to this MAC address. This IP address map to this MAC address. And it pretty much creates a table so that it doesn't have to repeat its information again and again, right? So, but it likes to keep an updated information. So example, like who has pretty much your broadcast says who has 10.1.5.0, and when replies, it stores information, goes to like the entire subnet and gets it stored, right? Each computer or each host will have an ARP table itself, and more ARP broadcast. Okay, bigger subnet equals more ARP broadcast. ARP traffic can become a large portion of a network load itself because it's telling every device that where everything is located and what the MAC address is. Pretty much on a 4.29 billion host network, right? It becomes a very big table for all the hosts to memorize and store in its memory, right? So it crashes the system. Okay, that is why we split them up into smaller networks as much as we can to manage them. Summary is larger broadcast domain slows the network because all devices receive every broadcast. Broadcast storm consumes bandwidth. Switch floods traffic everywhere. Device-based CPU processing, um, i- i- irrelevant packets. ARP traffic grows with network size itself. Okay. And this is why that controlling broadcast or having a smaller network, it means a lot. And this is what the last IP address on your network does, which is the 255. Okay, you cannot go past 255. You cannot use 255. The most you can use is 254. Okay, on any network. And when we do the little bit of more in the thing, we'll let you know. So to reduce broadcast domain size by creating smaller subnets, using VLANs. We'll talk about VLANs in the next classes. Implementing layer 3 segmentations, controlling unnecessary broadcast-based protocols. These are some of the things that we can do to control these type of issues happening in the network itself. Okay, and these are some things that will be asked you in the exam as well. What are some of the things you can do to reduce broadcast storms? And these are some of the key points that you guys might have to memorize, and one of these will be in the exam itself. Okay. Okay. So, any questions so far, guys? So, and this is just a quick introduction to IPv6, and we'll go back to IPv4 again. Remember, we talked about IPv4 being numbers only. It's a 32-bit system, complete 32-bit system, broken up into 8 sections, right? 8-bit, 4 sections, right? 4 octets itself. Whereas IPv6 is a 16 symbols, whereas IPv4 is 0 to 9, right? It's 0 to 9. The reason why it's 0 to 9 is we use our hands, right, to count, right? So it's always 0 to 9 for IPv4. It's a basic counting system, right? Whereas IPv6 is more advanced. It uses 16 symbols, which binary was based out of two, right? It's a 2, 0, and 1, whereas IPv6 is a decimal is based out of 10. So it's decimal is based out of 0 to 9, which is 10. Hexadecimal value is 0 to F. So it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F. And this is what you guys have to memorize for IPv6. Okay, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Whereas IPv4, it's 1, 2, 4, 8, 16, 32, 64, 128. For IPv6, this is the table itself. Okay, hexadecimal has 16 values in total. Each value is 4 binary bits or 1 nibble. So when you guys see the term nibble, always remember this is referring to an IPv6 addressing scheme. Okay, 1 nibble is half a byte. 1 byte equals 8 bits. And this is a basic conversion that you guys might want to memorize or write down. Okay. Any questions here, guys, so far? So this is a binary conversion table for IPv6 for binary and hexadecimal. Okay. And this is decimal and hexadecimal. So I just split it, so just to fit into the screen, I split it up into two sections, but it travels like this, right? It goes from 0 to 15 because zeros in a computer form still counts as one, right? Instead of 16 decimals, it's from 0 to 15. It's if you count the numbers, it'll be 16, okay? Because a zero is still considered as a one when you do it mathematically, right? So that's the reason why. But this is a format that you guys will have to memorize. Each one of these is called nibbles itself. Okay, over here. Each one of these is a nibbles, and this is what a nibble means. Okay. You guys want to might take a screenshot or something like this so you guys can um, make your own tables, but or you can get this from Google as well. I just created on Sheets, right? So this is the thing that you might want to quickly write this down on an exam if they ask you for some sort of conversion in IPv6, which is very, very low in CCNA right now. They might ask you for a certain bit value or nibble value. If they ask is what is a f nibble value, or what is a zeros nibble value, or binary value, or hexadecimal value, or something like that, right? So this is what you have to write down to memorize it. And the quickest way I always do it for myself is I write down the first value and the last value, and then everything else is just adds. You just add in the one right in between and move the one each different values in, right? So just memorize this for your exam. It's part of your memorization that you have to do. Okay? And this is the table how it look like. So converting hex to converting counting in hex. Sorry, remembering binary was 1, 2, 4, 8, 16, 32, 64, 128, right? For hex, it's 16-bit counting system. So it'll go from 1, 2, 3, 4, 5, 6, and then it goes like that till 16, right? Because remember in here, I'll show you here. In this one we looked at 1 to 8, right? So whereas if we're going to go down to binary, it's hex itself, this will go from 16, 14, one, right? This is how it would go. This is what hex counting will look like, right? And each one of these will have its value like this, and it adds on it adds on pretty big numbers to 56 uh 056, sorry. 4056 and 36, and the number just adds on top and then goes, right? So it goes in that counting itself, and it goes up and it becomes a very, very large number. I think when we looked at the conversion for or when we looked at the possible outcome for IPv6, it was like 32 octillion or something, right? So when you go up to 16, that is the outcome you would be in. Okay, so that's just the introduction to IPv6. We'll cover more of it in other videos, but IPv4 is where we want to just start off with, and then we'll go back into IPv6 again. Okay, let's go into IPv4 fundamentals. And for this, I want to do is I want to go in here. second here. Let me move this here. Okay. Okay. So IPv4, as we talked about, IPv4 is a 32-bit system, right? 32-bit system. So which means this was created by I. This would be definitely asked in your exam, IFT, which stands for Internet Engineering Task Force. Engineering Task Force. Okay. So if they're the one who created this IPv6 formatting. There's 5 classes in IPv4. It's 5 subdivisions. Okay, and I'll explain what it is. There's class A, B, C, D, E. These 2 are for CCNP level. We will not be covering this. I'll just go overview and I'll tell you what they are. But the ranges for this, there's a ranges that it counts, okay, for these classes. These ones goes from 0 to 127. For B, it goes from 128 to 191. For C, it goes from 192 to 223. For D, it goes from 224 to 239, and sorry, for E it's 240 to 255. These are the ranges for IPv4 classes ranges, okay? And this you do have to memorize this one, these ranges, okay? But even if these ranges are given, right, it doesn't mean that you can use all of these, okay? And I'll explain what I mean by you cannot use all of it one by one, okay? And remember that it's it's a total of, the binary conversion, right? What we looked at in the table, how it works, right? It's total of 32 bits, and there's the numbering scheme and everything, right? So just memorize that. We've seen that before. But let's go through each one of those classes right now, which I'll line over here. Are you guys able to understand my handwriting? Is that okay or is it bad?
Uh, I can understand it.
Okay, thank you. Yeah, thank you. Okay, so first let's look at class A. Okay, this has a range of 0 to 127. The only thing that you have to know is anything that is within the 127 0.0.0. This is called a loopback address, okay, in the class A. So this is used for self-testing, which means you cannot use this this address for assigned any devices. This is used for testing purposes, okay? To check, to make sure if the port itself is working. It's a self-testing, okay? So you cannot use this IP address on a Class A network. It's already predefined itself, okay? And also, you cannot use 0.0.0.0, because remember that the starting, it says it's starting at 0, right? And it's ending at 127. So you cannot still use this one over here. Sorry, use this one over here, okay? It's still not possible because this is considered as a default. Sorry. This is considered as a default route. Itself. And when we go into more of router configuration, and I'll explain to you why this is very important. This one you cannot assign it. It's considered as an invalid IP address to be assigned for a device itself. Okay. It's we'll address this in the router when we go into the router section itself. Okay. So, but we see here it says that we can use a range for Class A. We're saying that the rules are saying that we can use from 0 to 127, but what we can realistically use is 1 to 126. Okay, that is a range that which we can use. Okay, that is a range which we can use it. So, which means our first available IP address on a Class A network that we can use is 1.0.0.0, which would be considered as the network address, okay? ND, network address. Network address, okay? Network address itself, okay? This one, it's assigned to when a network starts. Remember we talked about this. The first IP address you cannot use. It's burnt away completely, right? The 0 itself. So the first available IP address is actually 1.0.0.1, which is considered as VIP, which equals valid IP address. Okay. VIP means valid IP address, just so you guys know, and we'll be talking. We'll be using the VIP term a lot, which means a valid IP address. Okay, that's what it means. So it can remember in a Class C IP address. What we can do is, remember in the last class, if you guys remember, what we talked about is when a subnet mask is listed as 255 255 255.0, and the IP address is 192.168.0.1. Sorry, guys. This section is considered as this is considered as a network portion, right? And this is considered as a host portion itself. So this is a Class C, but on a Class A, how it works is maybe 1.0.0.1, right? So which means your subnet mask would look like 255.0.0.0. So what should make this is your network, which will make this as a host itself. So it allow for maximum amount of computer to be joined to the network itself. And I'll tell you what the numbering will look like. And it's a very high degree of computers you can connect, host you can connect. But sorry. So if we come back to this place over here, the ranges which we can go up to here for this one it'll be considered as maximum we can use is um, 1.255.255.254. That's the last one, right? It's the last VIP of the network, of this network. Okay. And what will be the broadcast, guys? What would be considered a broadcast IP address for this network?
Is that not 255.255.255.0?
That's a subnet mask, right?
Okay, okay,
So
okay.
yeah. So the you're almost close. So what would be
And
considered
with
as
255.
ends with 255. Very good. So it'll be 1.255.255.255. This would be called broadcast. This will be the last one. We cannot use this one, right? So this is considered as a broadcast itself. Okay. So now, if you might think this is all filled up, right? No, because now we can switch into another network as well. Now we have from 1 to 126. Remember from here, right? We can use from here. We can use maximum up to 126 from here, right? So what we can do is when we the next network will start with 2.0.0.0, which would be network address. 2.0.0.1 would be the starting for the network address itself, the starting valid IP address, and then 2.255.255.254 would be the last BIP, and then 2.255.255.255 would be the broadcast. And it'll keep on going like this until it reaches the 200 126. Just give me 1 second, guys. Sorry. Okay. Yeah. So that's how it just keeps on adding the network. The thing that you have to remember is that's how the class A will add on, and the more network you can have, right? One of the caveats that will happen when you start creating network like this. Remember, we have a network here. Let's say this is its own universe, right? This world has a network starts with one dot. The network is 0.0. Okay, this is the network because network can be 0.0, right? And we have another one over here, which is 2.0.0.0. These things cannot. They don't see each other. They have no visibility. Any computer, any host inside here that has starting with 0.0.1 to 1.255.255.255.254 can talk to each other, but they cannot talk outside this network itself, right? So where this would become, when we go into the more of a router section, we'll learn how to do a connections to make sure that they can still talk if we do need them to talk. Okay, so we can create certain connections for them to talk. We'll go when we go into the router section, and we'll talk about that. Okay, and it's not a too hard of a concept. You guys will start understanding once this is understand for you guys. Okay, are you guys understanding how the class A works? Any questions so far, guys? Any questions so far? Everyone is understanding, staying in the pace, or bit lost? So if you guys do need to me to explain it a different way, let me know. I can explain it differently. Not a problem at all. But I just want to make sure that we get these information in for you guys. So it will be a very essential things that you guys need to understand. Okay. So that is for class A. Now for class B, so the ranges for class B 128 to 191, right? So this is what we can use. Because this is not something that it's zero, or it's something that is considered as an invalid IP address. We can use pretty much starting at 128 all the way to 192. Okay, so how this would look like from a networking standpoint or a host standpoint is there's available networks. Okay, is 16 bits, and host is equal 16 bits. What we mean by this is, okay, so remember in a subnet mask, right? We'll look at a subnet mask. It's easier for us to understand. On a class B network, it'll be 255.255.0.0 for a class B address, right? Which means these two are your network portion and these two are your host portion. And how do we come up with 16-bit is, remember each octet, so these are octet itself, right? This is an octet, this is an octet, this is an octet, right, over here. Each one of these octets hold a value of 8, right? So if we add these two, there's 16 for the network, and then for the host, there's 16. So we calculate based out of power of 2, remember? For binary, it's power of 2, right? Because there's one is 0 and a 1. So what we do is 2 to the power of 16, which gives us, I'm not very good in math today, 2 to the power of 16 is 65,536. That is the available amount of network we can have. That is available amount of host we can have, right? Because 16, 16. Now, if we want to go back to this one over here, let's say we will go to class A, which I forgot to explain to you guys on this one. So this one, remember that there's oh yeah, this is class A, right? So class A, so what this would mean for the class A is, for the network, there is 8 bits. For the host, there is 24 bits, right? Which means 2 to the power of 24 would equal so that's what, 16 million addresses, 16 million possible hosts what we can have. And this is what we meant by broadcast storms and broadcast issue, right? On a class A network, if you have 16 million hosts available, imagine the level of request each computer receiving from the broadcast. Remember, it has to, your switches will try to send to each one of those 16 million address to see where everyone's located, right? Possible addressing, right? So imagine the level of slowness you'll have, the amount of packet losses which you'll have, right? So that is why it's not very feasible. And just to give you guys a back-end context, the level of networking what we have right now is never been anticipated when they created internet first, right? So internet was always a military project before. It was never a civilian. It was never to be used by average human being. It was a military project, right? So it was never looked at these degree of usage right now. But because we have, every one of us have what, I myself have my iPad, my laptop, my cell phone. Each one of these will need an IP address, right? to connect to the internet and do its work. If we were to get a physical connection for each one of these, it will not be feasible, it just would be thing, right? So our router will issue these things, but remember, ISP has a bigger version of the router we have at home, right? That's how it works. Everything works in the same basis itself, basics, right? So in that concept, when we start having bigger networks, it creates a lot of issue for broadcast itself. Okay, so that's the reason why we like to split them into smaller networks, so each network can handle its own broadcast network itself. And then at home, we use class C, and we'll look at class C again. But let me go back down to class B. Okay, any question, guys, about the concept we have covered so far? We'll go to class B and I explain this one. And please, guys, if you have questions, please ask. Just want to, make sure that you guys have all the answers you guys need. Okay. And if I'm going too fast, please let me know. Okay. So let's start with this. So, okay. So from what we talked about here, what do you guys think the starting IP address ranges would be like? Mm, any guesses? Okay, so I'll tell you this. The starting IP address ranges would be 128.0.0.0, which would be the network address, right? This would be considered as a network address itself. And then you'd have your 128.0.0.1, which should be your VIP, right? Which is valid IP address, right? First available valid IP address. And this would go until 128.0.255.254, which should be the last valid IP address. Your broadcast will be 128.0.255.255, which would be a broadcast. And then it goes on just like this. We can create another network here. Like, yeah, go ahead.
Can you just change the color of the pencil?
Yeah.
Yes,
You
yes.
want? Yeah. No problem. Thank you for saying that. I'll make it into red. Is this better? That's too light. Hold on 1 second. Let me increase the. Is that too? Let me zoom in a little bit more. It's not very. Is that seeable? Is that good stroke enough? I don't think that's thick enough, eh?
No, I don't think so.
Yeah, I don't think that's thick enough. Let's see here if I can. Okay, let me see if I can. Okay, what I'll do is this. Let me zoom in here. I think if I zoom in and if I write, this will be much more easier for you guys, I think. I'll keep this at a 50% zoom as well. Okay. So I think this would start making more. Okay. So let me see here. Okay. Okay. I think that should be very good for you guys right now. I think. Let me see. That's perfect, right?
Yes, that's good.
Perfect. Perfect. Yeah. Thank you. Thank you for letting me know. Because for me, when I see it on my screen, it's different than what you guys can see, right? So it's better that you guys let me know right away, okay? If you guys don't see something. Okay, perfect. And yeah, so what we just talked about is, just give me 1 second, is the starting, which is a starting IP address, right? Which is, remember we talked about 128. And okay, perfect. So we talked about 128, 0.0.0 being the network. The next available IP address that we can start using, once that is done, the 0.0.1 to 0.0.254 is done, we can use 128.1.0.0, which would be the network address. Just going right over here for you guys. And then so I want you guys to give me the first available VIP, valid IP address, and the last available VIP address for this class B. And remember that class B's subnet mask is 255.255.0.0. This is a class B's subnet mask format. So with that in mind, what do you think would be the first available and the last available IP address for this range? Valid IP address range. Come on, guys. There's no thing as wrong answers. So, if you once you guys just guess. There's nothing wrong with guessing, right? So, all right, I'm going to start picking now. Janisha, what do you think the first starting IP address would be like for this one? No right or wrong answers, right? Don't be afraid. Manjeet, what do you think the
Okay.
first?
One
Sorry,
first VIP might be 128.1.0.1.
128.1.0.1. Perfect. Very good. Very good. Very good. What do you think the last available valid IP address range would be like?
That one, not sure.
Okay, no worries. You're on the right track. So the last, yeah, go ahead, go ahead. Okay, no problem, no problem. Gabrielle, I
254.
understand. Sorry.
It will end with 254.
Can you give me in the full IP format?
Yeah,
What?
128.1.0
Yep. Oh, sorry.
dot
Okay, give me 1 second. Say it again, Imran. Sorry. 128. Yep.
128.1.0.
Yep.
Sorry. Yeah, dot 0 dot 254.
Um, maybe not 0. Let's say
Yeah,
the subnet mask,
254,
right?
254.
Not 254. Dot 254. The reason's because you see this number over here. We can go maximum of 254 here, right? Because remember that we could still go in with the first available host IP address. We can go up to 255. Not a big deal. It's the last one we cannot go to 255, right? So it could be 255.254 here. This is a valid IP range for this network itself. Does that make sense, guys?
So
Mhm.
in the class B network,
Mhm.
when we see the subnet mask, because subnet mask also tells like what class subnet mask it is. If you
Yes.
so so we have dot 0 dot 0, which means like this is where it can be increased.
Yes. It allows for us to add in more as we need.
All right.
Yeah, and the maximum we can go up to is 255. And the 255 each one of these, right? This can go up to 255, and this can go up to 255. The only reason why in this last one we cannot go to 255 is because it'll be considered as a broadcast, right? The 255. It's already been taken. It's not that we cannot use. It's just that it's already been used for broadcast, right? The last one. But this one is still possible, very possible for us to go to 255 here. But
All
because
right.
these are,
So
yeah,
so
yeah,
121.1.255.254. This 254 is because the one is already taken because it is
exactly.
the first initialized server
Yeah,
network, and this 255 is remaining. But over here, dot 0, which is the third one, it's because it's already classified, so it is
mhm.
full 255 because there's nothing used.
Yeah, it's not been defined yet, right? So
Yeah.
imagine automatically when you create a network, the last one, the 255, the last available IP address is already been reserved. You before you even touch it, it's already been taken away, right? And the first one, which is 0, it's already been taken away. It's there, but it's already been taken away. So that's the reason why in the last one we cannot use the 255. It's always will be taken away, and the first one, which is a 0, it's always taken away. We can use from the first one to 254. Okay. Awesome. Any questions here, guys? Okay. Perfect. So now, and the maximum we can go up to this on this network, and the other things you can go down to is you can from 128 you can go all the way to 191, right? So if you go, you can go the same way and create networks, multiple networks like this, and the last one would be 191. Sorry. Dot. Um, I'm just going to do the last thing over here. Okay, 191.255.0.0, right? Because remember the subnet mask is already at 0.0, so this would be considered as our last available network address itself, right? That we can use, which means our valid IP address ranges for this one 191.255.0.1 all the way to 191.255.255.254. This would be considered as our valid IP ranges for the class B addressing. Okay. We can start from where it starts from is here, right? So let me do the starting and ending over here. So let me just do it over here. That's not a problem. So it'll start from 128.0.0.0. That's the network address, right? To all the way to 192.255.0.0. This is sorry, 255. This is your network range. Your valid IP ranges. This is your network range. Okay. Your valid IP ranges would be like 128.0.0.1, and it can be anywhere to 192.255.255.254. This is a valid range for the class B itself. Okay. Valid IP range. Does that make sense, guys? Any questions here? Did I confuse anyone?
No, that these are lots of networks.
Sorry. Yeah, exactly. Yeah, you got the point, right? It's a very big network, which means we can do 65,000, I believe, right? If it's a 2 to the power of 16. Um, it's around 65,000 available network that we can use just on a class B itself, right? Just want to. So sorry. The reason why I'm going back and forth is because the antibiotics I'm on, it's causing me a foggy brain thing, so I can't think properly. Yeah, it's 65,000 available hosts, okay, and available network as well. So that's the reason why it is a class B is a very big network, and it's used in a lot of corporate environment too. Just to let you guys know, a lot of enterprise networks uses class B. Class A is used for ISP. It's not really usable in a core. It's just not manageable, easily manageable. They use either class B or class C. At home, you guys will be using class C, which is what we will go right now. Okay. Okay. Any question on class B, guys? Okay, so this would be considered as your class C. Class C, okay? The class C subnet mask goes like this. Subnet mask goes like this: 255.255.255.0. Okay, which means these are all locked for network itself, and this is for host, right? So which means in a network, we have 2 to the power of, what is it, 8, 16, 24. And for this host, we have 2 to the power of 8, right? So it's a very low amount of hosts that which we have, okay? So, but a class C network range is, remember what we talked about is for the range itself is 192 to 223. That is a range that a class C address can stay within, okay? So the network is 24 bits, host is 8 bits. Okay. And this is very manageable, right? So if it's 8-bit, how many hosts can we have, guys? Remember from the binary table what we looked at? How many hosts do you think we can have? 254, right? That is the max. So remember when we looked at the binary tables, right? Where is it here? Hmm. Remember each octet had a 8-bit, right? And each one of those bits is valued at what? Remember this table here we looked at? It's 8-bit, right? So when you add all of these up, this will become 255, right? But because one gets burnt away, we can only use 254. Remember this one over here, this table, the 8-bit, right? So when 8 bits available, we can use maximum of 255 because one gets burnt away, 254. Okay. Let me zoom out and go back to the section here. So on a class C network, we have 192 to 223, the range we can use, okay? Which means our network address will start with 192.0.0.0, right? Which would be the network address. So if you go on your computer CMD and type in ipconfig, see, I'll show you my thing over here, my CMD. See here, my IP address range is 192, which is a class C, right? And see the subnet mask over here? It's 255.255.255, right? So which means in my home network, I can have a maximum of 254 devices connected, which on a home network, it's very sorry, it's more than enough, right? You don't need 200 plus devices on a home network. Well, first of all, your router will not be able to handle 200 devices because it's too many devices. But on a home network itself, it's not, you don't need any 200 devices to be connected, right? A maximum on a home device you'll connect is 50 to 60 device. That is at a very at the IoT devices and a lot of those devices. 50 device is considered as a very high limitation for a home device itself. Okay, so almost all home devices are on the Class C network, and you can obviously see that by the subnet mask. Now, sometimes I have seen Rogers routers. Sometimes starts with 10 dot on a, but there will be a Class C. The subnet mask will be a Class C definition itself, and it's because of this. New thing which we'll talk about. It's called CDIR, which we'll talk about as well just later on this course. It's CIDR, sorry, CIDR. We'll talk about it just a little bit later on in the course. It's just a classless interdomain routing value. So with that, you don't have to really follow this class values, but it's not very it's not very seem like it doesn't seem like that, but you go by a subnet value itself. Okay, that's the reason why I want to show you guys that. But here, let's go back to our drawing board here. This would be the network address, right? um, what do you guys think would be the valid IP address ranges for this network address would be?
192.0.0.1
Very good. 2
to 192.0.0.254
dot 0 dot
dot 0
250.
dot
Yeah,
254.
very good. Very good. Very good. This would be considered as your the valid IP address, right? Very good. And then your broadcast would be 192.0.0.255 would be a broadcast. Broadcast, okay? This would be your starting value, right? So, and then you can add on more network on top, and how that would work is, so this would be considered as one network, right? And then what we can do is 192.0.1.1.0. This would be your network address. And it would work the same exact way. We'll do the same exact way. You'll go from 192.0.1.1 to 192.0.1.254. This would be considered as your, your thing, right? Your whip. And this numbers will add on and add on, add on. You can go as many like that. Remember, the available networks is 2 to the power of 24, which is what 16. I believe that's 16 million addresses, right? Network addresses you can create from this. 2 to the power of 24, which means it's 16 million, I think. Yeah, 16 million. So your possible outcome of different networks you can have is 16 million different networks address you can have. And that's 16 million different type of networks, the combinations you can make from this, okay? The class B address range. And do you guys understand what I mean by the network is? Network and host, right? When I say 16 million network possibilities versus 16 million host. So this is your network range over here, right? This is your network range. So different. So remember we talked about the universe, right? So remember when we went over here and we talked about the circle. So okay, let me just draw it here. So remember this guy, we just created a new universe here, right? Saying that, you know what, this guy in this universe can talk to anyone in the 192.0.0.0 universe, right? And we create another universe saying that, which is 192.0.1.0 network, right? And we create another universe here. We can create another universe, 192.0.2.0. And we can go on like this infinite amount of time until we reach the last available, the address, which is 223.255.255.0. This is the last network range we can use, and which would give us approximately 16 million ranges, 16 million different type of network we can create. And think of that like creating a new universe or something like that, right? So we call it ring theory, universe theory, ring theory or universe theory, right? So you have the possibility of creating new universe. With a class B, you can create up to 16 million. With a class B, you can create up to, what is it, 65,000. With a class A, you can create 254, right? Because the network only has 8-bit, right? In a class A, 254, which is very less. Does that make sense, guys? Any questions about this? Did I make it difficult, or did I make it easy for you guys to understand this?
It's easy. The last thing you said, very less, is in class C, right? Not the class A.
So if you think about it, less meaning, if you talk about host, less available host is in class C, but there's a lot of networks available in class C as well. You can create different networks, right? Different universe. Like imagine like creating different universes, right? Creating different networks. In class C is easier with a limited amount of host, with 254 hosts, but you can create 16 million different networks with a class C. Whereas a class
Yes.
A, you can have more hosts, but less network, the least amount of network. Because it's meant for like ISP, right? Like it's meant for internet service providers, or pretty much like a very large scale, like enterprise.
Yes.
Yeah, very good. Manjeet and Janushya, you guys have any questions? Are you guys clear with the concept?
Yes, it's clear.
Very good. Yeah, Janushya, are you clear? Okay. I think Janushya is probably is at work or something like that. That's fine. No problem at all. Let's see if okay. So let me it's up here. So that is ranges for class A to C. Now there's 5 classes I mentioned at when I said IP ranges, right? The other ranges are class D. The range is 224 to 239. So this is used for, remember what we talked about, we're not going to touch this concept. This is for CCNP level, right? So this is used for multicast communication. Okay. And usually class A, B, and C is considered as unicast, which means it's one-to-one communication. Just think of like unicast being one-to-one communication, multicast being one-to-many communication. And then we also have something called broadcast, which is one-to-many. Okay. Multicast is like it's almost a group-based subscription type of thing. Okay, it's a group-based subscription communication type of thing. But whereas unicast is one-to-one communication, which is class A, B, and C. This one would be asked in your will be asked in your exam as well. Just memorize that class A, B, and C are all unicast communication. It's a one-to-one communication. Okay, it's a one-to-one communication. It's not a multicast communication itself. Um, Multicast means one to a group messaging. So it's like almost like imagine like your WhatsApp group. You're sending a message to a WhatsApp group or sending a message to a group itself. It has to be subscription based. Okay, and this is usually covered in CCNP level. It's a different concept. It's a different level of training itself. Okay, which we will not be touching in this class. That is a range for class D, and then class E range. This range is 240 to 255. Now, with Class E, there's actually a bit of a thing here. Class E is considered as reserved for research and development purposes. Okay, and this range is not really given to many people. It has to be approved by I believe it's IEFFE. They have to be approved it to make sure that it is actually you're doing a research, and you do need that range to do your testing for you to be routed online or outside. There's a hefty process. It is a very hefty process, and they can revoke saying that you cannot have this IP address ranges. Right? It's a very it's a very it's a very it's only given to certain organization for certain purposes only. It's not for everyone, right? So that's the reason why. Okay, and it's they have to find it legitimately. You need this range to do your operations in. But if you see if you see the the ranges here, what we talked about, I'll show you an example of a Class B IP address. Is remember I told you guys recently we were moved from a shared for our LMS. You moved from a shared LMS to a dedicated LMS, so our ranges were a bit different. Right now, our IP address range is different. It's in a Class B range, which I will share the thing here with you guys. And you guys do the same. You guys can try this on your computer too. If you guys just do a ping and ctech training.ca, which is an LMS portal, right? And you see this IP address range starts with 172.64.80.1. This is a Class B range, right? Because if you look into our notes for Class B, our range is, you know, our range for Class B is within the 128 to 191, right? So 170, 172 falls in this range. It is a Class B, okay? It is considered a Class B address. Because it's a dedicated own server from a cloud services itself, okay? It is a Class B address, and that's how it changes, and because it allows them to have multiple hosts. It gives them an even amount of hosts versus even amount of network itself, right? So we have our own network that we use. Okay. So, any questions about the classifications about these subnets? I know it is a lot of math on a Sunday morning, guys. I'm sorry, but it's just something that we have to cover for you guys to understand. But any questions, guys, before we move on to the next concepts? So, I only have a few more things I have to cover before I'm sorry for the torture for today. This won't happen like this, but it's just we have to cover this. Okay. So next is always remember any IP address you assign must have a subnet mask. Okay, and remember for Class A, and you guys do have to memorize this. Okay, Class B, Class C. So the ranges for this, I'll give you just example IP address ranges, right? If it's 10.1.1.1, the subnet mask will never change for Class A. Just the IP address is just example, but subnet mask will be 255.0.0.0, right? And Class B would be like if we can say 172.16.168.1.1. The subnet mask would be 255.255.0.0, right? Whereas Class C, this would be 192.168.0.1. Subnet mask would be 255.255.255.0, right? This would be your subnet mask for these, right? Now, it's when you're doing programming and when you're doing like assigning on a router on a large scale, they came up with something called CIDR, which is what I mentioned before. It's CIDR is just a basic calculational. It's a calculation value, right? That they've used to identify the subnet mask. So you don't have to type in 255.255.255.0. It's just annoying, right? So it's a calculation system based out of power of two, right? Which is what remember I mentioned by the bits, right? The bits itself, because binary uses power two, right? It's 0 and 1, so it's 2-bit. So it's a power 2 to the power of 2, right? So anything just powered by the 2 itself. So if you consider this, right, Class A, which has 8 bits, right? So it's only using 8 bits because the first octet is only full, right? So it's 8 bits. So a CDR value for this would be /8 for this Class A over here. Let's put this up. So class so the reason why CDR will help you realize it, it's easier for when you see on a Linux or on a router, you always see a /8/24/32. It tells you more about how many bits are available, or how many network you can connect to it, or how many hosts that can available you can connect to it, right? So usually it's counted by the used up network, or the network itself, right? So if it's 255, it's the first, it's 8-bit that's used, right? So this would be class A is considered CIDR value is /8. It's /8, okay? And then for class B, the CIDR value would be /16, because remember the two 255s are two octets of its full, right? So 255, 255, 8-bit, which is 16, right? So this would be /16, the CIDR value, okay? CIDR, which stands for classless inter domain routing value. This is what it stands for, okay? Classless interdomain routing value, okay? CIDR. And you'll see this getting used in a lot of Linux, a lot of routers now, a lot of switches and everything. It's getting used CIDR value. It's very easy, so you don't have to. It saves you so much time, right? And for class C, what do you guys think the class C CIDR value would be?
24.
Very good. So be /24. And how did you get up to 24, Manjeet?
Just based on the host thing.
Yeah,
It's
exactly.
total 38, 32 bits.
Yeah, and then you have three of them used, which is 24, right? 8, right? So 16 plus another 8 is 24, right? Perfect, very good. And this is how the CIDR value is counted. And there's a different range, and I'll send you guys a small picture about it. The CIDR value range. It's on it's on Google. I'll just open it up and I'll show you guys. It's called CIDR value tables. So I'll show you guys here. Oh, so let me share this. So it's just, it talks about the power to the 2, right? So it talks about the available. It's a power to the 2. It's all. So it goes from all the way from 2 to the power of 0 to 2 to the power of 32, because we have 32-bit in our IP range, right? So that's the maximum with a 4.29 billion available IP address, and it's at 0. The CIDR value is /0 because you can't add any more host or anything to it, right? Because it's completely used up. But then the lowest you can go up to is /32, which means all of it is used up too. Okay, all the hosts has been used up. But I'll send you guys this one, this website. It's a very good read that you guys can do to understand a little bit more about CIDR values and how it, how it's developed and how it's getting used right now. Okay, I'll put this on in an email for you guys. Just once we're done the class. Okay, but sure. Okay, so that's all I have for today on the IP address and subnet mask. I hope I didn't confuse you guys, and I gave you guys very good explanation about IP address and subnetting to make it a little bit more simple for you guys. Just wanted to know any questions, any concerns about IP addressing or subnetting for IPv4 addresses. Or were you guys able to understand today's lecture? Was it helpful for you guys?
Yes, it was easy.
Yeah. Very good, very good. Yeah, and in the next coming class, I'll show you guys There's another easier way to calculate these two. There's another easier way. I'll show you guys very quickly on it. So when you go into the exam, you can start doing the calculations, especially that, the table I showed you. Just write down 128, 64, 32, 84. It gives you guys, when you guys in the exam, it gives you guys a little bit more leverage to, calculate them very easily. Okay. All right, very good, guys. So from next class, we'll actually start practicing on packet tracers and doing some programming on the switches and getting the concept of the switches and routers and programming them from next week. I think that's what we're going to start on next week. And sorry that last week I had to cancel the class, is because I was just way too sick, as you can see. I'm almost recovered at a 90% recovery range, but yeah, last week it was just horrible, horrible, horrible. That's the reason why I got this, okay? But sorry. But before we end today's class, any questions, guys, about this? Okay, perfect. Yeah, and as you guys see, IP address is a very simple concept, but it's something that you guys will have to memorize, and there's certain things that you guys have to memorize, and just keep practicing, with IP address, whatever you guys see, and once you guys understand this, everything you'll see will start to make sense to you. What is Class C? What is Class B? What is Class A? And you'll start seeing. And then what I mentioned is some of them are doing now CIDR, where Rogers routers are coming with 10.0.0.1, but then your subnet mask will be 255.255.255.0, is because they're using the CIDR values instead of the traditional way of doing it, which is not a wrong way. It's just it was never a traditional way, right? Because of CIDR, they can do that still with using a Class A IP address, but using a different subnet range, right? And you guys will start seeing that on a Rogers router, which I've seen. But I think they stopped doing it now is because it did create a lot of issues with people when they were doing work from home, because their work VPN will think that they're using a Class A IP address, while their internal IP address is still Class A. So it creates a bit of an issue, which we'll talk about in the later classes as well, in our troubleshooting classes, which we'll go over it. Okay. But thank you for joining in today, guys. I'll see you guys next week at 9 a.m. Okay, sure. And
Thank
before
you.
we
Take care.
thank you. And before we go, just 1 second. 27th and 28th will be a holiday for us. It's a Christmas holiday, right? So it'll be a holiday for us. The week of the 25th till 29th, it'll be considered as a holiday for us. Okay. So the class on 28th will be scheduled for next week, which is January 4th. Okay. So just to give you guys a heads up. But next week we do have a class on the 21st. Okay. Before the holidays. Okay, guys. Thank you so
Okay,
much.
thank you.
Thank you. Thank you. Have a wonderful day. Okay. I'll see you guys next week.
Thank you.
Thank you. Thank you.